What's up, everyone? In this lesson, we're going to be talking about volume and surface area of spheres. So remember that surface area is the area of every single face of your shape. So this includes the bases and all of the other lateral faces. And also remember that volume is the space that's occupied within the boundary of a 3D shape. Another word to think about this is the capacity of a 3D shape, right? Like how much space, how much stuff can it hold? And since we have 3 dimensions, our units are cubed for volume. So for our sphere formulas, the volume formula is nicely given to us on our reference sheet, so you don't have to remember this. But anyways, we have 4 over 3 times pi r cubed. And then our surface area formula is not given to us though. The surface area formula is 4 times pi r squared. So this one, you do have to try to commit to memory. Now, if we take a reference sheet visit, you can see that the sphere volume formula is right here. And also notice, like, this whole entire region, or this whole portion of the reference sheet, is all volume. So make sure you're aware of that so you can find things quicker. So some prior knowledge is just be on the lookout for when you're given the circumference of a circle. When you are given the circumference, you're able to figure out the diameter. So if you go into this example right here, if we're given that the circumference is 20 pi, if we're given to it in this format, we know that the number right next to pi is our diameter. So in this case, if we were given that the circumference is 20 pi, we can also say, hey, the diameter of our circle is then 20, which in turn, we can also conclude that 10 is the radius. Now, if the circumference is given to you without pi in it, you can still find what the diameter is. So again, you guys got to start getting triggered in your brain when you see the circumference given to you, you're able and you should find the diameter. Otherwise, they wouldn't give you the circumference. They just give you the radius if they wanted to. If they give you the circumference, you have to go the extra step. So if it doesn't have pi in it, clearly you can't use the logic, hey, the number right next to pi is your diameter, because there is no pi in here. But what you can do is rewrite the formula. So pi d, we can substitute in for the circumference, right, equals 36. And then to get the d, to get diameter, you divide by pi on both sides. And in your calculator, you would literally type in 36 divided by pi. That would give you your diameter. And then you divide that by 2 to find your radius. So you're going to have to need that. You're going to have to use that as we do today's lesson. Now, skill number 1 is just finding volume and surface area. So we have a basketball in the shape of a sphere with a circumference of 29.5 inches. And we want to figure out the volume and the surface area of the basketball to the nearest cubic inch. So we see this word circumference here. We're given the circumference. We need to trigger in our brain to make some conclusions. Because for volume, first of all, it's 4 over 3 times pi r cubed. We don't have the radius yet. And for surface area, it's SA equals 4 pi r squared. Now the r, the radius, is in both of these equations. We don't have it yet, so we have to use the given info. So we know that our circumference is 29.5 inches. So instead of writing circumference, we write pi d equals 29.5, and we divide both sides by pi here to get our diameter. And when we do that, we get that our diameter is 9.39 ... And then we divide that by 2 to get our radius. So our radius is 4.695. So when we substitute, we have v equals 4 over 3 times pi. Our radius now is 4.695, and we are cubing that. And then you can go ahead and plug that right into your calculator. We get that our volume is 433.506 inches cubed. Now we want it to the nearest inch, the nearest cubic inch, so we have 434 inches cubed. And that's going to be our volume of our basketball. Now for surface area, we can go ahead and substitute our radius in. We have 4 times pi. Our radius is 4.695, but here we're only squaring that. And you can go right to your calculator. Since we're getting it to the nearest inch, you could just put pi right into your calculator. And here we get 309.776, and again, we're rounding to the nearest cubic inch, so we get 310 inches cubed for our surface area. All right, now last but not least, going into the second scale of all of these figures was, instead of solving for the volume, we're given the volume and we gotta work backwards. So it says the surface area of a sphere is represented by 144 pi. SA equals 144 pi. And it wants us to find the radius of the sphere. So if we rewrite our formula, SA equals 4 pi r squared, we can now substitute in our surface area value. Our surface area value is 144 pi equals 4 pi r squared. Now what we should see is there's pi on both sides of the equation. We know those are going to divide out, so we can rewrite it as 144 equals 4 times r squared. So to begin isolating this r squared, we're going to divide by 4 on both sides. And we're going to get 36 equals r squared. And then we take the square root, and we get that 6 is our radius. So we know our radius, right? We had our surface area, we were able to figure out our radius. But now what we can go is, what else can we find? Well, guess what? Now that we have our radius, we can find a lot of things. We could find the diameter. The diameter is 12. We can figure out the circumference. The circumference is going to be 12 pi. We can also figure out the volume. Now the volume is a bigger portion of what we would want here. So volume is 4 over 3 pi r cubed. And now that we have our radius, we can just substitute that in here, put that in our calculator, and we'd be able to get the volume. So this is interesting because we started with surface area, and we were able to get all the way to our volume just from that, okay? So again, just be mindful, our volume formula for a sphere is here on our reference sheet, and the surface area formula we do not get. So you want to make sure you make a little bit of a note of that on your reference sheet so that you have it when you go back.